Good morning. My name's Tom Tenner, and this is Rachel Muller, and we're from Aspect Software. And we were kind of joking yesterday about what we should say about us. And we have 50 years of contact center experience, and I don't know who wants to claim more between
Bob
the
has
two
40.
of us.
I mean, Tom is 49.
Right. So, Aspect Software. Today we'll spend a little time talking about Aspect Software's journey to the cloud and how we used API Gateway and Lambda and our experience with those, some of the things we've learned, some of the best practices we've found, some of the help we got. I'll also introduce our technical account manager. Hassan's name is up there, but Hassan's been very helpful as well. So his name is on the presentation. Aspect Software is a customer engagement center solutions company. And for over 40 years, we've helped companies contact their customers. And in 1973, we introduced the first automatic call distributor, or ACD, which really changed the call centers of the time. In the 80s, we added outbound dialers, workforce management software, and computer telephony integration. Now, chances are good that if you made your flight arrangements to Vegas or you confirmed them, that you probably had some contact with Aspect products behind the scenes. Now, one of the things with the automatic call distributor, those were huge hardware beasts, and they took up lots of space in customer data centers. And when we added workforce management software and the dialers, they became very large. But just last year, we introduced Aspect Via, which is built for the cloud and deployed with Amazon Web Services. Some of the features that we have for Aspect Via are inbound and outbound multi-channel customer engagement. That's for voice, chat, email, and channels like that. We have skills-based routing to get those contacts to the agents who can handle them. There's self-service channels for text and chat and other things. And we have analytics, reporting, and workforce management. Those are some of the features that we have. And now that we're built for the cloud, we don't have that same footprint we did with huge stacks of hardware in the data centers. Now, this is a marketing slide I stole, and it's one of the slides they use to show that we use a number of Amazon Web Services to deploy Aspect Via. S3, EC2, Elastic Load Balancers, Kinesis, SQS, RDS. We use a lot of those things for the desktops in the contact centers to connect to our communications channels. We also have the services we provide our NOC. But the point we'll talk about today is the public APIs that we provide our customers so they can control, monitor, and configure Aspect Via and how it allows them to engage with their customers. And we did that using API Gateway and Lambda.
Before we get into the meat of the presentation, I'm just going to do a brief history of Aspect's evolution into the cloud. Like many of you, Aspect traditionally installed applications in the customer data center. And this kind of involved telling the customer, hey, we need this much compute, this much memory, this much storage to make our applications run efficiently. And then the customer would go and procure the necessary hardware from their preferred vendor. You know, HP, IBM, et cetera. And as you can imagine, this meant that there was quite a varied deployment environment for us. And we leveraged server virtualization from VMware and Microsoft as much as we could to kind of mitigate the variation. But we still had to contend with different OS versions, the customers running antivirus software of their choice, backup agents, network monitoring software, all in the same operating systems instances as our applications. And then to complicate matters, Aspect manufactured its own media servers. And those had to be shipped to the customer site. They had to be racked, stacked, connected, configured. And this made for a very complex deployment situation. We spent a lot of time writing install scripts and procedures and sending armies of people on site to make sure that this all went as smoothly as possible. And typically, the average deployment took weeks and then sometimes months to occur. Fast forward to VIA, and one of the primary requirements was that we deploy in the Amazon cloud. And this opened up all sorts of possibilities for deployment efficiencies. So in the beginning, we mostly took what used to run in virtual machines and moved them to EC2 instances. But as time has gone on and opportunities have arisen, we've tried to leverage serverless technologies, in particular Lambda functions. And for those that aren't familiar with Lambda, it's a service in Amazon where you can take your code, upload it into Amazon, and then Amazon takes care of the deploying and the scaling of that application. Now, this is a snapshot of what our deployments look like today. Most of the services are running in the Amazon cloud, but we still have our media servers running outside the cloud, but in our own data centers. So nothing runs in the customer premise anymore. And now our deployments take hours. But we're not done yet. We want to get to continuous delivery in the end. And the first thing we want to do to get down that road is to move our media servers into the Amazon cloud. And then secondly, we want to get out of the business of installing during deployment time. So installs need to become a build artifact. And then it's containers that we will deploy when Lambda isn't a good choice. And we'll leverage EC2 containers and Elastic Beanstalk for that purpose. So now we can get sort of into the main theme of the presentation, which is about our journey to deploy our first set of REST endpoints for Aspect VIA. As Tom mentioned, we have a major requirement in Aspect VIA to allow our customers to control and monitor VIA programmatically. And this enables VIA to better integrate and interface with the customer's business processes. But now we had a couple of challenges. One was, how do you get those requests into the cloud securely? And secondly, how do you ensure that those requests are processed efficiently and that one client's requests don't overwhelm those of another? We did some investigation of a number of API gateways, and in the end, we settled on the Amazon API gateway. The gateway has the ability to perform all sorts of validation on the requests prior to being processed by our end services. It can validate the path, the query parameters, the post properties, and there's also the ability to do early authentication. We have the API gateway integrated with our own identity management platform. And that way, any requests that come in that don't have a valid token or are missing an OAuth token will get rejected right away. Also, the API gateway has a throttling configuration setting, a number of them, so that on a per client basis, you can limit how many requests come in at a certain time or over a period of time. We wanted to, as part of our REST API design, take advantage of serverless technologies as much as possible because we want to be spending less time writing deployment scripts and more time adding features. So Lambda was an ingredient there. And lastly, we needed an effective way to communicate our APIs with our consumers, whether those were internal VIA components or our professional services department or our customers. And after some investigation, we settled on the OpenAPI specification. Anybody familiar with OpenAPI or Swagger? Yeah? Oh, great. Got a couple. Terrific. For those that aren't familiar, I'm just going to do a little aside here. Because OpenAPI ended up being such an important and integral part of our REST API design, the OpenAPI specification is language for defining REST endpoints. It's sponsored by the Linux Foundation, and there are a number of major contributors, including Google, IBM, and Microsoft. And sometimes OpenAPI is confused with Swagger, because Swagger was the original name of the specification. But today, Swagger represents the open source tool set which can facilitate the design and implementation of APIs that are written using the API specification. So bottom line is OpenAPI is the spec, and Swagger is the tool set. Next, I'm going to show you some of the benefits of using the OpenAPI spec and the Swagger toolset. Here's an example of one of our endpoints as depicted in the OpenAPI spec. And you can see, I can get this, oh, there we go. At the top there's our URL. And you can also specify verbs, whichever ones the endpoint's going to support. You can also specify, this is a GET request, so there's a number of responses that could come back. And here, the endpoint is defined as something called the Swagger editor. That's one of the Swagger tools. You don't have to use the Swagger editor. There's a number of plugins for Visual Studio, Eclipse, and a number of developer portals that will facilitate the creation of this OpenAPI specification language. And typically, what we do is, we define a group of endpoints that are functionally similar. We put them in the same file, and we call it a Swagger file, and I'm going to refer to it as that from now on. So now we have our Swagger file, and this becomes our source of truth for deploying our endpoints. We use this, we give this Swagger file to our customers. They create clients from the Swagger file. We give it to our doc folks, they create documentation from it. Our QA department takes this same file, creates clients which are used to test the endpoints. We also use it to facilitate our deployment of the endpoints in the API gateway. So here's an example of client generation. Here's a tool, the Generate Client tab here represents the Swagger tool CodeGen. And you can see here there's a number of languages in which you can generate clients. And for our customers, that means we can just give them the Swagger file, and then they can go generate clients in whatever language they prefer. And then Aspect gets out of the business of building and maintaining SDKs. So here's an example of what the Java representation is of one of our endpoints. It's a little hard to see, but we didn't create any of that code. That all came from CodeGen. You can also create documentation. And here's the HTML representation of the endpoint you saw earlier in the Swagger file. It's a little hard to see, but at the top here this is the endpoint itself. And what's kind of nice is that you get little tabs here that show you various ways to invoke the endpoint in different languages, which can be very helpful to get an idea of how to interact with the API. And then you can provide a lot of descriptions of properties, whether those are path parameters or here's the response properties. So if you do a good job of writing descriptions in your Swagger file, you can come up with some pretty comprehensive help files. And lastly here, I mentioned that we leverage the Swagger file for deploying APIs in the API gateway. And here you can see in the Amazon API Gateway console, there is the ability to import Swagger files. We do it programmatically through our deployment scripts, but I just wanted to show you that it is possible here. And I'll go into a little bit more detail about that later.
We'll talk about a few of the use cases that utilize API Gateway and Lambda. And the first one is voicemail. Everybody knows voicemail, and we provide that to the agents in our contact centers for when they're on the phone or away from their desk, busy with other work. And we looked at the usage pattern for voicemail, and it's one of those things that's really pretty sporadic. You may know that all the agents will check it when they get in the mornings, but then there's breaks when they finish with calls. You really can't anticipate too much of the traffic that you're going to get. And then when they come off a break, 100 or 200 agents come off a break, you may get a burst of requests that are well beyond what you might have expected. So in the legacy world, we calculated our peak request rate, and then we provisioned the systems, and we deployed the legacy voicemail web service across multiple different virtual machines. And it sat there 24/7 waiting to handle requests. And that just wasn't the model we could actually do in the cloud. We didn't want to follow that model, and we changed that. It was definitely a compelling use case for Lambda, which will scale up and meet the demands that you need, and you only pay for what you use. So that was the compelling case for Lambda. So this is also a migration story for this particular service where we deployed the original voicemail web service on EC2 instances. We had internal clients talking to that. Then we added in the new voicemail endpoint with API gateway. So now we had a scalable RESTful interface with security and the interface we wanted to expose to our internal and external clients. And we temporarily created a redirect Lambda, which would take those requests, transform them, and then redirect them through the load balancer to our voicemail web service. This allowed external clients, internal and external clients, and our developers to work in parallel. So another developer team was working on the new voicemail Lambda function. They were able to do that in parallel. That was added in, layered in. We were able to remove the redirect Lambda and then have internal clients use API gateway, which finally allowed us to remove and retire the original voicemail service. Now this gave us the final architecture that we wanted for voicemail. So some of the key points for this migration was API gateway allowed us to deploy the new type of RESTful interface we wanted. It allowed us to do the migration. It hid the internal implementation of the services from the original non-RESTful, non-scalable services. So when we were able to migrate to the Lambda, and it allowed for that migration. And Lambda was great for the serverless, scalable, just what we needed for this service. Now, something I didn't talk about yet was cold start. And cold start's the delay that it takes for Amazon to start your container, load any language resources, load your Lambda function package, and then call it so it can initialize itself before it even takes its first request. And anytime you take in your Lambda function initializing, that's going to add to the cold start delay. So with the voicemail service, we were able to minimize the delay with some best practices, but we also, with voicemail, were able to sustain a little bit of a delay, which is not something we could with our next use case, which we'll talk about now. The next use case was for a low latency microservice, and it also deals with voice recordings, but in this case, it's recordings that Aspect Via does of customer interactions. A lot of companies want to keep track of interactions when you call your 401k company and say, I want to sell everything. They want to keep a recording of that, so in 6 months or a year when you call back, they can say, well, no, you asked for this. But one of the things they don't want to do is they don't want to record any sensitive data, your account number, codes. If it's healthcare related, there's other information they don't want to record because of either regulation or industry standards. So the voice recording web service that we have provides the ability to pause and not only start and stop recordings, but pause them temporarily. So when we have an interaction, and this is an example of one with Nicole, our customer service rep, is talking to Elaine and asks her for account number. This particular customer doesn't want to record that, so Elaine pushes a button, it pauses the recording, she speaks the recording, we resume, and the key thing here is that these events that come from the agent's desktop that go through the internet to the cloud and to our recording web service have to occur very quickly with the smallest delay possible. Any additional latency is going to risk either making the conversation awkward or it's going to record her account number. So both of those things we want to minimize.
So as Tom explained, we had some severe time constraints on control of recordings. In particular, we need to process a recording control request within 200 milliseconds. So when we were asked to build a REST API for recording control, we had to take this limit into consideration. And that allowed us to come up with a couple of major criteria. One was that we wanted the minimum number of components in the path of the processing of the request, obviously, because the fewer the hops, the less time it's going to take to process. And the second is that we wanted the path to be secure and constrained, meaning that the request had to come to the API gateway, it had to go to an application load balancer in a private subnet, and then on to the recording control web services, which were behind that load balancer. However, what we found was that this particular design is not something we can do right now because you can't send requests from the API gateway to a component that's in a private subnet today. And we've talked with our technical account managers about this, and they brought it to the API gateway team, and we have learned that this is on the roadmap, but it is not available today, so we couldn't consider this design. Next, we decided to promote the application load balancer into a public subnet because you can send requests from the API gateway to a component in a public subnet. However, we soon discovered that if you put something in a public subnet, it can be hit directly from the internet, and there really wasn't an easy way for us to control that. So while this design does meet the fewest components in the path requirement, it didn't meet the constrained secure path, so we rejected this design. We then considered adding a Lambda to the design, and this did indeed meet the requirements of a secure constrained path because you can't trigger Lambdas from the internet. They have to go through the API gateway. And we were able to code the Lambda function so that it only communicated with application load balancer in the private subnet. However, we've now added a component to the path, and indeed a component that had some variable startup time associated with it. As Tom mentioned, Lambda functions can incur cold starts. And while there's a number of mechanisms that you can use to ensure that Lambdas remain in a warm state and that they don't incur a cold start, if you send enough concurrent requests to it, at some point you're going to incur a cold start. And indeed, our research and some load testing we did prove that out, and so we couldn't take that risk, and we did not choose this design either. In the end, what we ended up doing was taking our own reverse proxy and then configuring that to send the requests onto the application load balancer in the private subnet. And while this met both our requirements of minimum components in the path and the secure constrained path, we got none of the benefits of the API gateway. The reverse proxy has minimal provisions for validating requests and tokens, and has minimal capacity to throttle requests. So in the end, we really couldn't make a public API set for recording control. We only allowed these APIs to be used by internal components via the browser components, and until such time that we can get the capabilities of the API gateway that we need. The last two sections of the presentation go into a little bit more detail about our journey of deploying our first REST endpoints for VIA and some of the things we learned that we wanted to share with you related specifically to the API gateway and Lambda. Whenever we consider third-party services to be integrated with VIA, whether that's from Amazon or anybody else, we always consider costs as part of that criteria. With the API gateway, there's added complexity because each of your endpoints is going to have potentially a different usage pattern, and that will impact how much cost the API gateway service is going to be for you. So for each endpoint that you are planning on designing, before you implement it, you need to consider how often is that endpoint going to be called. Is it on a per user basis? Is it periodic? And then you need to consider that for all your endpoints in aggregate and calculate the monthly cost of the API gateway for that, and then add that to your cost of goods, or how much it's going to cost you to deploy your solution. And then you need to compare that against how much revenue or margin you expect to make off of your solution. And if the API gateway costs impinge on those profits, you want to consider a couple of options. One is that you can throttle the requests. Indeed, here you can see the API gateway has what's called a usage plan, and this allows you to control the number of requests, the rate at which requests come in, as well as quotas, how many can come in for a certain time period, and those will be measured against each client separately. Another alternative you have is to bill your consumers. So let them use whatever they want, but then track it and bill them for it. I talked up the Open API spec and Swagger tool set a little while ago, and we were able to take advantage of the Swagger tool, the Swagger editor in particular, as part of the review cycle and collaborating with the various teams that were building the REST APIs. And this gave us a consistent way to present the APIs as we were reviewing them. And we talked a lot about, how the endpoints would be used and the property naming conventions and what resources we would expose. What we didn't do was we didn't bring the consumers of the API into this discussion early on. They didn't get their first crack at interacting with these APIs until the services were implemented. And this caused a lot of problems for us. We got lots of late feedback, missing endpoints, missing properties. I don't know how to use this endpoint. And it caused a lot of churn in our first iteration of the development cycle. A lot of late changes, and actually reduced considerably our capacity to deploy all the endpoints we wanted to in the first iteration. So the bottom line here is you want to make sure that before you implement your back-end services, that everybody's in agreement about the APIs, in particular the consumers, because they know how they're going to use them. Similarly, it's important that the consumers get early interaction with your API endpoints. Oftentimes, even a review won't uncover some nuances that actually interacting with the API might reveal. And again, we suffered a bit from the fact that we waited so long to let the consumers have access to the endpoints. So now we use a couple of strategies. One is the mock interface in the API gateway. As you can see here, there's the ability, especially with gets, to put in canned data. So at least your consumers are able to start to play around with the API. You can get early feedback and make changes when it's cheap to do so in the early stages rather than late when it's really expensive. Also, I talked about before how we use Swagger to facilitate the deployment of the APIs into the API gateway. And on the left here, you can see an example of one of our Swagger files. We call it a customer Swagger file because it's ready for our customers to generate clients from or documentation. However, it doesn't have all the information that the API gateway needs in order to process those endpoints. In particular, it doesn't have any information about the Lambda function or the HTTP endpoint that might be processing the request. Secondly, while the API gateway can import Swagger files, it's not 100% compliant with the Open API 2.0 spec. In particular, it will reject any Swagger files that contain the property examples. You can see in here we have an example, which is something you want to share with your customers, but it was being rejected by the API gateway. So we've spoken to our technical account manager and the API gateway team about our concerns about the incompatibility, but we've recommended that they move on to supporting the Open API 3.0 specification, which came out in July, rather than fixing the 2.0 version. So here I'm going to show you what it takes to take a customer Swagger and transform it into what is necessary for the API gateway. Right now, these two files on the left and the right here look the same, but you see here, the first thing that has to happen is you have to take out the examples. And then secondly, you have to add in the part that says who's going to process the request. The Open API spec supports what's called custom extensions. And here are the ones that Amazon has for the API gateway. And you can see that one of them there is specifically used to indicate which Lambda function is going to process that endpoint. So once we discovered that we couldn't just import our Swagger files without some changes into the API gateway, we also realized we didn't have time in our first iteration to do any automation around that. And we thought we could sort of soldier through it, make some manual edits and kind of be done with it. And this is the process we had. Every team was given a group of endpoints that they were responsible for, a functional grouping, if you will, of endpoints. And they would have to manually update those files, take out the examples, add in the API gateway extensions, and then check the file into source control. Then we had another group which took everybody's Swagger files and merged them together because we wanted the endpoints to be imported as a whole into a single stage into the API gateway. And then they did some more editing of the file to get it ready for our build scripts. Then lastly, we deploy the monolithic Swagger file into the API gateway. And you can see here how many places where manual update occurs. It's a little hard to see in the middle, but there's 2 arrows there for manual update. And this caused us a lot of challenges. We had a lot of problems where there was missing API gateway extensions, so there was no Lambda that was specified to process an endpoint. We had fixes made to endpoints at the API gateway that didn't make it back to the Swagger file. We spent a lot of time fixing the same problems over and over and over again. And again, this reduced our capacity and our ability to deploy a lot of public endpoints in our first iteration. So needless to say, in our next iteration, we wasted no time in automating this process. And this is what we do today. So the teams are still responsible for their particular group of endpoints, and they check those into source control, but they don't do anything to the files. They're ready to go for the customers. Nothing's removed, nothing's added. Then we have a nightly build script, which takes all the Swagger files and does all the necessary transformations, merges the files together into the monolithic Swagger file. And then lastly, we have that same build script import this monolithic Swagger file into the API gateway, and if anything goes wrong through any of these stages, the developers are notified in the morning and they can fix the problem. So all these things combined, early reviewing of Swagger files, early interaction of consumers with those endpoints, automating the transformation of the Swagger files to import into the API gateway has enabled us just in 2017 to go from deploying just 8 endpoints in our first iteration to now over 85.
There's also a number of Lambda lessons learned. Just as Rachel talked about the usage patterns for API Gateway, it's also something for Lambda. You'll want to understand the usage patterns so you can calculate not only cost of goods and services, and that's something almost became a mantra for me to the teams. What's your COGS? What's your COGS? They got tired of hearing that. But you want to calculate the cost of goods and services, but also the cost in time and what you're actually going to be doing. So you make sure you choose the right model for whether Lambda's the right choice. It might be possible for some of the long-running services where you want to choose a deployment in Elastic Beanstalk. And I know we've done that in a few cases for things that just have to run and have to be there. And we have the Elastic Beanstalk will scale up and meet those requests. So understand your usage pattern, understand the costs in time and money that'll. The next thing is speed, or is the Lambda language choice. And one of the factors in choosing the Lambda is what developer skills you have. And we found that we don't have, for all the languages that are available for Lambda, we have a more limited set of choices for which languages we actually want to choose. So we've deployed services with JavaScript, Java, and with .NET Core. And Java is the slowest for the cold start, for the things that when Amazon loads the container, loads the language resources, it's the slowest one. But once running, it's the fastest. And I know the Amazon team has told us they continue to work on the cold start, but There's also the impact you have in your code on the cold start as well. Another point to keep in mind with the speed is be aware of what libraries you use. And in Java, one of the good examples is Spring Boot. If you use Spring Boot, it's going to do introspection all over the place. That's going to cost you. So might not be a factor. You may be able to handle that and it'll be fine. One of our processes does do that. But be aware, because that can be a big place to spend time that you can't afford. Another good recommendation is to use the Lambda proxy mode integration over using the custom integration. The Lambda proxy mode takes some of the work and passes it on to the developer to do when they get the call from API Gateway. They can do more of the parsing of the requests and then format the responses. And it simplifies the swagger that you have to provide. And it's definitely a better way to go for the integration. Here's an example. Rachel kind of alluded to it before, but the swagger that's on the screen now is what you need for the custom integration. There's lots of things that you have to define. The swagger for the proxy integration is somewhat less complicated, and there are only 2 API Gateway extensions that need to be added. The most important one being which Lambda function to use on the bottom. The AWS developers, the Lambda developer guide is a great resource. Over the course of time that we've been using Lambda, Amazon has increased the number of recommendations in their best practices section. It's grown a lot. It's a lot of new things to consider, and they've been very helpful. So I'd recommend finding the best practices, looking through those, and see which ones can affect you. Here's one example that we had to do in a number of our Lambdas is make sure to do one-time initialization in global scope. And this applies to all the languages. In this example here in Java, we're creating an S3 client. And do that once. Now, there's a cold start penalty for doing it, but where you're going to get the benefit is when you get additional requests that come in, it's not going to affect your subsequent invocations. You only created the S3 client once. You're not creating it every time a request comes in, which would affect each request. So take advantage of doing the initialization in global scope. Be aware of memory and its resources. You want to make sure that your packages that you're uploading are as small as possible. That has an effect on how quickly the container can load and how quickly it will initialize. So get rid of resources that you don't need. Get rid of libraries you don't need, and deploy the smaller packages. Next point, do cleanup. Close and dispose of objects. It's something we should be doing anyway. But make sure you get rid of them so those things don't stay around and affect subsequent invocations, especially if there's outstanding asynchronous calls or threads. Make sure to do cleanup. Get rid of it. And then lastly, keep in mind the memory. Now, most of us would think we want to have the smallest amount of memory for a Lambda function because there's a cost. The more memory that you have, the higher the cost. But associated with memory, as you increase memory, there's also an increase in the CPU that goes along with it in the containers that they're running. And sometimes, if you have more memory in CPU, that request that you're handling may finish more quickly with more memory, and they really cost you less money than it would if you had a smaller amount of memory. So there is a tool out there. You can go and test this yourself, but there is a tool. I believe it's called the Lambda Power Tuning. If you search for that in your search engine, it's not an Amazon thing, but it's built with step functions. It helps you test your Lambda function to find the best profile for memory. So I'd recommend going to check that out and running it against some of your Lambda functions and checking what memory setting is best. Lambda stateless. Shouldn't be saving stuff in Lambda. If you do need to save things, Elasticache or DynamoDB are great choices. If you have requests from a client's API coming in and you need to save things, use Elasticache or DynamoDB or both, whichever ones make sense. We've had some good luck with those. But you can also take careful advantage of the fact that the container is going to be around, and when you have subsequent invocations, you can, for static data, you can store it in memory if it's not too large. You could also, there's a temp directory, you can take advantage of putting some things there. But if Amazon scales down and the container goes away, this stuff goes away. So if it's really important, put in an Elasticache. You can take advantage of memory and the temp directory if it fits. We've done it in a couple cases for speed. And then the last thing is function warming. Rachel mentioned it. It's one of these things where you can make requests to keep the Lambda function, the containers alive. That way you don't have to fight with cold start. You have to make enough requests so you can handle your peak requested rates that we talked about for the legacy. You may have to make a lot of requests to keep multiple containers alive if that's how many you need. You need to do testing for that. One way of doing the function warming, though, is you can use CloudWatch scheduled events. That's one of the recommendations, and Amazon has pages that kind of describe how to do that. CloudWatch metrics. CloudWatch metrics, and I will try not to forget to say CloudWatch logs. You probably know about those, but we definitely have seen the benefit of using the CloudWatch metrics, and the metrics are across many of the Amazon products. But for API Gateway and Lambda, it's been invaluable for us to see how is it, are we getting the number of requests we're expecting? Are we having errors? How is it performing? How's the time? Rachel actually was looking at metrics and found one of our clients that was making far more requests than we expected, costing us more money. Mm-hmm. And we were able to find that just by looking at the metrics themselves. You can go ahead and create custom metrics as well. On the screen here, you see X-Ray, Amazon's X-Ray product, which allows you to trace requests across. I don't have a slide showing it, but it allows you to trace requests across Amazon services from API Gateway to Lambda and onto other services. Something to take advantage of. And here's an example of one of the things. This was actually from production where we had lots of invocations and lots of errors. So it can be helpful to narrow down and find problems. And another thing is Amazon support. Aspect is lucky enough to have the enterprise support. We have technical account managers like Hassan that have been with us from the beginning. They walked us through a document that they have that's the well-architected framework. And it takes you through 5 pillars Amazon has identified to have a well-architected cloud application built on Amazon's products. So that was very helpful for us to go through. Some of those things we did really good on. Some of the things we saw areas for improvement. But that's one of the ways they can help with best practices and guidance. They also have proactive support and knowledge sharing. Sometimes we'll get calls and Hassan or Greg will tell us that we're approaching certain limits in the account, and we may want to make a support request to increase those limits. So that helps. And we've also had some access to a number of different Amazon experts. Last year at reInvent, we were able to meet with the API Gateway and Lambda folks. We might have that opportunity this year. Along the time, they've set up calls with us. So the enterprise support has been very helpful, and we appreciate their help along the way for getting us to the cloud.
So we shared a lot of things with you today, and if we just had a few things we wanted to leave you with, one is that if you're like us and you're taking some monolithic applications and rebuilding them, re-architecting them as software as a service in the cloud, build APIs and use that as a tool to protect your consumers against all the changes in the plumbing and components and whatnot that's going on underneath the covers. But as you build APIs, you need to consider the costs of those with the API gateway. So know your usage patterns before you implement. We recommend the Open API specification for communicating your APIs with your consumers and creating your source of truth. And lastly, even though it's not the default option, the Lambda proxy integration is far simpler unless you have complex needs for mapping templates and such. So that's all we have to share with you today. And we'd love, if anybody is using API Gateway and Swagger Open API, we'd love to talk to you and share experiences. We're really hoping we can do that while we're here at reInvent. Thank you. Any questions?